Let's look at one other example of how we can use a solubility product. In this case, let's imagine we have a solution where we have, for example, chloride, or let's do mercury, where we have mercury in solution and no chloride present. So the mercury is happy to be there as an ion. And the question is, if we add chloride into the solution, at what concentration will we start to get precipitate present? So let's say we have mercury present at a concentration of 1.5 times 10 to the minus 4 molar. So not very concentrated, but much higher than the sort of concentrations we were looking at. The question is, at what concentration of chloride will we start to see precipitate forming? Now remember, KSP represents an equilibrium between the solid, salt, and the aqueous forms of the ion. And let me not forget that there's two chlorides here. That is important. And let me keep it from being covered up by my face here. There we go. Okay, and so if we don't have any chloride present, we won't have any solid present. That's pretty obvious. But we want to know, when are we going to start seeing precipitate form? Now, when we have sufficiently low concentrations of mercury 2 and chloride, mercury 1 and chloride, we will be below KSP. We can think about this in terms of Q and KSP. If Q is less than KSP, then our reaction will proceed to the right. And in this case, that means that we won't see any solid forming. We'll start to see solid when Q equals KSP, solid will start to form, because then the reaction will start to shift to the left. So to answer this question of what concentration of chloride is necessary, we just want to find out, when is Q going to equal KSP? Okay, so our KSP is 1.2 times 10 to the minus 18. We know the concentration of mercury, that's given in the problem, 1.5 times 10 to the minus 4 molar. And so then the question is, what is our concentration of chloride? We'll call X. And that needs to be squared because of because that's the stoichiometric coefficient on the chloride. What is the value of X that will lead this to be equal to each other? Okay, so we can solve this. Divide by 1.5 times 10 to the minus 4. And then we're going to have to take the square root. So we can say that X is equal to the square root of 1.2 times 10 to the minus 18 divided by 1.5 times 10 to the minus 4. So let's go ahead and enter that into my calculator here. Square root of 1.2 times 10 to the minus 18 divided by 1.5 times 10 to the minus 4 equals 8.9 times 10 to the minus 8. And again, this will always get concentrations in molarity here when we're talking about aqueous solutions. Okay, so when our concentration of chloride reaches 8.9 times 10 to the minus 8 molar, we will start to see precipitate forming, and our mercury will start leaving solution. As we keep increasing the concentration of chloride, we'll get more solid that will form.